Good evening. This is a video demonstration of the reinforcement learning agent application for assignment 2 of AI2 course, roll number M20CS056. In the code.zip file, you will find a rlegend.exe file. When you open this exe file, this is the application that opens up. This application simulates a reinforcement learning agent, specifically a Q learning agent on this board, where the task of the agent is to start from this position and reach to the goal position. Now the initial configuration of the goal position is as given in the question, but you can use this reposition goal button to randomly reposition the goal within the question's constraints. Now the UI shows the current iteration, the number of steps taken, the total reward collected in this iteration, and this square here shows the possible actions for the agent. So the agent cannot go left, cannot go down, can only go right and up, and the reward for this particular state. You will notice that the reward is negative, and this is because we want to incentivize the agent to quickly find a path to the goal node instead of roaming around in the environment trying to collect more and more reward. The UI shows the current recommended action of the agent in green. So this is the action the agent will take in the next step. And when you hover over the UI, you will find you will see the Q value, frequency, and exploration value for taking this action from the current position. Uh, Now, the learning rate and other parameters for this agent are learning rate 0.2, discount factor 0.8. The reward function is actually -1 into Manhattan distance of current position into goal. As I explained, we want to incentivize the agent to find the shortest path to the goal and not roam around. The exploration function incentivizes the agent to actually take different routes from what it has taken before. So if the frequency is greater than 0, that is if the agent has taken the current action, then it will multiply the Q value with the frequency. Otherwise it will use the Q value. We are multiplying the Q value with the frequency because the Q value is bound to be negative thanks to our negative reward, which means that the more the agent takes a certain action, the more negative the exploration function's value will be, and the agent actually selects action based on the largest exploration function value. uh, At the right here, you will see the current path taken by the action for every iteration. So we're in the iteration 1, and this button makes the agent go one step forward. So if I go one step forward, you'll see that the agent moved up, and this is the new set of actions available to the agent. The agent will actually try to come back down here. So let's see, the agent came back down, and we know that from this position the agent tried to go up, so the frequency actually increased. The Q value and the exploration value will increase shortly. It's probably a very small value right now. So let's go a few more steps in. Okay, so from this state we just saw that the agent went down. We will see that the frequency has increased to 1 and the Q value is -1.8. Exploration is also -1.8. The agent has never gone right from this state, and it has never gone left from this state. Okay, so let's go a few more steps in. Okay, from this state we saw that the agent has gone up. So yes, the frequency for going up is 1 and Q value and exploration have been updated. The agent has never gone left from here, but the agent has actually gone down from here. So you can see that in this example, the agent chooses the action with the highest exploration. Both of these are negative, while here the while the left action has the exploration of 0, and the agent goes left. Now you can press this button to make the agent take steps until it reaches the goal, and I will do that right now. And we can see that the agent has now reached the goal, and in the first iteration it took 237 steps to reach the goal. The total amount of reward collected is -1768, and you can see the entire path taken by the agent in the right here. So you can scroll down for every step, and for every step you can for every location you can see that these were the actions available, and this Q value, frequency, and exploration is this Q value, frequency, and exploration value is actually the current values in the knowledge base. So this is not the Q value and frequency at step 24. No, this is these are the values that the agent knows right now in its knowledge base. So teleportation also works. So you can see that here when the agent reaches the teleportation node, the next step is next to the power position. This is because uh, although the UI shows that the agent is in this location, in the backend the agent is actually teleported to the power position, and the actions available to the agent are with respect to the power position. So you can see that the agent can go up and down. This is because in the power position it can go up and down. And similar cases for the teleportation to start position. So the start takes you back to the start. Now let's say we start the next iteration. The agent comes back to the start state. All the q values and frequency and all the data in the knowledge base is preserved, and now the agent will try to find a path to the goal node again. So I'll just reach goal now, and you can see that compared to the previous iteration, where in the previous iteration the agent took 238 steps and collected a reward of minus 1768, the agent now only took 22 steps and collected a reward of minus 147. So the reward is much higher, the number of steps are much lower, the agent is clearly learning a path to reach the goal node. And if you see the path history here, you can see that the agent actually took this teleporter to go to the power position, and from there it reached the goal node. Now let's try to reposition the goal. Let's say that we want the goal, yeah, to be there. Now if we tell the agent to reach the goal, it will reach the goal, but in much higher number of steps. It took 110 steps and collected minus 73 reward. Now, compared to the first iteration, it is still fewer steps and less reward, which means that the agent has learned to somehow get to this position. It's just getting from the previous goals position to the new goals position was uh, what made the agent take more steps in learning. So, if you scroll through the entire path, oh, also another factor in increasing the number of steps and the total number of rewards is the exploration function. The agent will always try to explore new states that it hasn't taken before, because every time it takes an action, the frequency for that action increases. So now in the previous two iterations, the agent took this bottom path and took this teleporter to reach the goal. So the frequencies of these actions of taking the bottom path have increased, and so you can see that the agent is trying to explore the top left region of the map as well here. Yeah, so the agent went all the way up there and then took this teleporter node which takes it to the power position. And then from the power position, it unfortunately took the restart node again, and this entire path. Okay, so it followed the middle path, took the teleporter from the power position teleporter, and then reached the top right section of the map, where it roamed around for a while and finally reached the goal node. So we can see that the agent agent's behavior depends on its knowledge about what it has learned about the map, and on the exploration function. If we disable the exploration function and only follow the q values, you can find the optimal path. And if you keep on increasing the number of iterations, you will notice that the agent explores more and more until there is like nothing left to explore. After that, it will just start repeating its behavior basically. The position history shows you a path followed by the agent, along with the total reward collected and the number of steps for every iteration that you perform. And to completely reset the agent, completely reset everything. So go back to iteration one, reset the q values and frequency and everything. You can press this button to restart the simulation. This is it. Thank you.